Hello, welcome to 7.4 Trig Identities. Just to get ready for proving the trig identities, for this particular sections, we're going to try to get the equivalent expressions for any of the given questions. So if you have the worksheets, you can follow me with all those examples that I'm going to show you, okay? So example number 1, simplify each in terms of cosine and sine, all right? So given the questions A, where we have a 1 plus the cotangent square theta, okay, so because everything has to be converted in terms of cosine and sine, then obviously any of the reciprocal trig expressions, we need to convert it back to the primary. So since we know that cotangent is the reciprocal of the tangent, and since tangent x is equal to the sine x over the cos x. So that means when it comes to the reciprocal of the tangent, we just need to reverse. Okay, reverse the sine x over cos x. So this will becomes a cos square theta over a sine square theta. So we have to follow. If this is a theta, then this has to be a theta. If this is an x, then we have to change that into an x. And then after you common denominator, okay, with the common denominator of sine square x, then you will have a sine square theta over here, and then plus a cos square theta. And because of the Pythagorean identities, we know that a sine square theta plus a cos square theta is going to give you 1. So therefore, the top here is going to give you 1, and the bottom here is going to be just a sine square theta. Okay, so this will be your final answer in terms of a sine. Okay, unless I have a reason to convert this back to in terms of cosine. But since this question is about either the cos or the sine, then so this one should be okay by just leaving like that. Okay, now looking at part B, okay, when you have a sine theta times cotangent theta minus sine square theta, cos theta, okay, same thing. We're going to make sure that everything converted in terms of sine and cos. So this one is going to be a sine theta times the cos theta over the sine theta, because this is the reciprocal of the tan. And over here, I still have the same thing, sine square theta and cos theta. Nothing need to be changed. But over here, because I can reduce that, so what I left with is just a cos theta minus the sine square theta cos theta. Now, because it has a two different trig ratio here, so if my final answer has to be in terms of one of the following, so that means if I'm looking into the common factors, so I can take the cos theta out, so that will becomes 1 minus a sine square theta. Okay, and because of the Pythagorean identities, I know that 1 minus a sine square theta will becomes the cos square theta. Okay, this becomes this. So finally, when you multiply everything, you will see that your final answer is going to be cos. When you multiply a cos theta with a cos square theta, you get a cos cube theta. Okay? So this will be the answer for part B. Continue with the example C, okay, when you have a cos theta times a 1 plus secant theta and times another cos theta minus 1. So, so first of all, because the only terms here is the reciprocal, so we are going to convert that back to the primary. So this is going to be 1 plus. This is going to be a 1 over the cos theta. Secant theta is the reciprocal of the cos, okay? And going to have the same thing over here. Okay, so let's change everything in terms of cos now. And because of the 1 plus the fractions, so we're going to have, make it a common denominator all of cos theta. So over here I have a cos theta plus the 1. Okay, and the second brackets remain the same. Now, because of after I change that into a fraction, so now I know that I can reduce that. So what is left basically is just a cos theta plus 1 times a cos theta minus 1. And this, I hope you recognize this as a difference of square. So you can basically take that as a cos square theta, this times that, and then a minus 1. Positive 1 times a negative 1 will give you that, okay? And because of the Pythagorean identities, you can also make that into a negative of a sine square theta. Okay? So we're looking for an answer that is in the simplified form. Okay? So because the Pythagorean identities, we have a 1 minus a cos square theta will give you the sine. So if you factor the negative out, then you will have a 1 minus a cos square theta here. So therefore 1 minus cos theta give you the sine square theta, but you have a minus right beside it. Okay, so that will be your part C. And part D, when you have a sine theta plus cos theta times a sine theta minus cos theta, okay, and plus the 2 cos square theta. Well, this will be a difference of square. So when you multiply this, you will get a sine square theta and a minus a cos square theta. Okay, and then together with the plus 2 cos square theta, okay, then you will, this is the like term. This is the like term, so when you combine this, so you have a sine square theta and a plus 1 cos square theta. And that basically is going to be equal to 1 because this come up to be the Pythagorean identities. Okay, so that is the part D. And now let's look at the E. And E, we have a fraction of a cosecant square theta minus a 3 cosecant theta plus 2 divided by cosecant square theta minus 1. Okay? For this question, there are a couple ways that you can do it. You can basically look at this and you can convert everything, the reciprocal, back to the primary. So that is one way of doing it. But if you look at the top here, the cosecant square theta minus a 3 cosecant theta plus 2, you can also look at that as a simple trinomial. Okay, if you let x be the cosecant theta, then you can basically rewrite the top here as a x squared minus a 3x plus the 2. Okay, and then divided by, then you will have a x squared minus 1. Okay, if that makes it better, instead of converting the cosecant into a 1 over sine, you can also do that, but I just thought that this could be an easier way to simplify these questions first. And of course, when you factor this, okay, when you factor this simple trinomial, and then the bottom will be the difference square. So x minus 1, x plus the 1. On the top here, x and the x. This is going to be plus 2, 2 and a 1. Okay, so is minus 2. This is a minus 1. Okay, minus 1, minus 2 give you a positive 2. Minus 2 and a minus 1 give you a minus 3x. Okay, so from here, you can certainly reduce that. So what is left? What is left is just the x minus 2 over x plus the 1. Okay, but x in fact is the cosecant. So I will rewrite this as a cosecant theta minus 2 over a cosecant theta plus the 1. So now I can turn everything into fractions. Okay, so I can have a cosecant turn into sine theta minus a 2. Okay, put in the bracket and divided by, I have a 1 over a sine theta, it's the reciprocal of the cosecant, and plus the 1. Okay, so now what I can do, so continue here. Now I can do a common denominator. So sine theta, so it's going to be a 1 minus 2 sine theta, because this one here is going to be 1 over 1 times the sine theta, so you get a 2 sine theta over here. And divided by, and this is going to be, again, common denominator, sine theta. So this is going to be a 1 plus a sine theta. Okay? And after that, you can flip by moving this divide, turn into a multiply. And now you can have a sine theta over here, 1 plus a sine theta over there. So you can reduce that. So what is left is going to be equal to 1 minus a 2 sine theta divided by a 1 plus sine theta. Okay? I'm going to leave it like that because I cannot further reduce that, but everything now is in terms of sine. Okay?